All right, so today we're going to be talking about comparing numbers in scientific notation. Now, this will probably end up being kind of a duh video, but oh well. So basically, when we compare numbers in scientific notation, there's a few ways we could go about it. So if we look at this problem, it wants me to just place the numbers or place the following numbers in order from least to greatest. Okay? So again, the whole point of writing numbers in scientific notation is to express really large numbers in a shorter form instead of writing like a million zeros, right? Or really small numbers, and again in a shorter form instead of, again, writing a million zeros. So if we look at these numbers, we could convert these all in the standard form and then compare them then. But there's a reason why scientific notation is a thing. It allows us to look at these really big numbers and just quickly evaluate them. And by looking at these numbers, like there's an obvious way that I can see which number is bigger and which number is lesser, and that is by looking at the exponents. Exponents tell me how many digits my number goes to, right? If it's 6, that means this decimal moves 6 spots to the right. If it's 4, it means it only moves 4 spots to the right. Which one's going to produce a bigger number? The one that moves more spots, right? So basically, we look at the exponents, and if they have the same exponent, then we look at the numbers in front and look at which one's bigger, which one's smaller. But basically, the bigger the exponent, the bigger the number. So if we look at these, it wants me to order from least to greatest. So we have 2 that are 4, that's the smallest exponent. 4.09 is less than 5.1, so this one is going to be the lesser number. And I'm just going to write the beginning number here, just for quick purposes. On your assignment, you'd want to write the whole thing times 10 to the 4. But it would be 4.09, then 5.1, and then the next biggest exponent is this 5 here, so 1.25, and then the next one would be the 6, which would be 7.8. So again, those would have like times 10 to the 4th, and this would be times 10 to the 5th, and times 10 to the 6th. That would be your biggest numbers. The next section, or the next one here, again wants me which of the following numbers is the least. So again, we're looking for the lesser exponent, which is 8. 7.1 is bigger than 7, so A would be the least number. And that's basically how this works, right? It's not too complicated. Which number is greater? These all have the same exponent. So 2.5 is less than 5, so obviously that is the less one. 5 is less than 5.25, but 5.55 is bigger than 5.25, so B, this one would be the greatest, okay? And really that's all you're doing here is just, again, looking for which one is the biggest and just ordering it, basically just answering the questions. But again, the trick here is just look at the exponents. The bigger the exponent, the bigger the number. Now, if it was a negative exponent, which I don't have any on here, but that would mean a lesser number, right? So if it was like 7.5 times 10 to the negative 6 compared to 7.5 times 10 to the negative 4, which one of those numbers would be bigger? Well, actually the one, this negative 4 is bigger because that's actually a greater number than negative 6, right? This is going to produce a much smaller number because, again, the exponent would move 6 spots to the left, making this a very small decimal, right? And this would only move 4 spots to the left, which again is a really small decimal, but it would be bigger than the 6 spots, okay? And that is basically, and I just did that all and you couldn't see it, but that's what I was talking about. So that is basically all you're doing for ordering.